Hi, welcome to another video in database internal series. So in the last video, we understood what separator keys are. And we briefly came across this thing where we saw that, okay, a B tree always typically has n keys and n+1 pointers. But I think I skipped why it is like so and what significant properties we would lose if both the child's pointers and the keys would be n. So let's first understand how this n+1 pointer scheme comes out to be. So each key in a B tree, it acts as a separator for the child nodes. Let's consider a node with n keys. Now keys, of course, they are sorted in ascending order. So we have k1, k2 until key is kn. Now there must be one child pointer before the first key and one after the last key and one pointer between each pair of keys. Now hence the math comes out to be for n keys we have n+1 pointers. So let's understand this with an example, and what each pointer represents also will get clear. So let's say we have a B tree node with n equals to 3 keys. Now let's say we have keys 10, 20 and 30 and we have 4 pointers, right? These 4 pointers are why? Because of this math that we just went through. For the child pointer, for the first key, there will be one before that, one pointer between each pair of keys and one pointer after the first key. So that's why there are n+1 pointers. Now we have 3 keys and 4 pointers. Now what do each of these pointers represent? So pointer P1 represents child with values less than 10, P2 represents child with values between 10 and 20, P3 represents values between 20 and 30, and P4 represents child with values greater than or equal to 30, right? So that is how typically a B tree node will look like. Now let's understand what will happen if both keys and pointers are n. So if we had only n child pointers, we would not have a pointer for the range greater than the last key. So let's try to run this example as well. So let's assume that we have 3 keys, and instead of 4 pointers, we now have P1, P2 and P3. Now keep in mind, these separator keys, they represent ranges. So range queries are one of the most important aspects of B trees, right? So let's understand how P1, P2, P3, if they would be able to represent all the ranges that are lesser than 10, between 10 and 20, between 20 and 30 and greater than 30, right? So let's assume that, okay, P1 still represents childs with values less than 10. P2 represents values childs with, let's say, ks belongs to a subtree which contains values greater than or equal to 10 and less than 20. And P3 now will represent values between 20 and 30, right? Now what happens is you essentially now do not have a way to search for values greater than 30. This is the limiting factor which comes when you have a B tree, or when you have a tree which has an equal number of nodes and equal number of pointers. You are essentially giving up on your range queries and essentially giving up on your search operation as well. So search operation will fail if both the number of child pointers and the number of keys in a B tree node are equal. So I hope this made sense, and I wanted to kind of cover it. Think it got missed in the last videos, and I hope this kind of clears why typically B trees have n keys and n+1 pointers, right? Thank you so much. I'll see you in the next one.